Alright, today we're talking about 3.3 or circular functions. So if you remember back to chapter 1 and 2 when we defined cosine and sine and tangent, we defined, for instance, like cosine of theta to be the x value over the r value and the sine of theta to be the y value over the r value. Now we're going to be only dealing with the unit circle, which is a circle of radius 1. So really, in our definitions, cosine theta x over r, we're dealing with r values of 1. So it's going to be x over 1 and y over 1 and so on and so forth. So we're defining our new cosine, sine, and tangent definitions as x over 1, y over 1, and y over x. And for secant, cosecant, and tangent, we just flip them again. So that doesn't change. The only difference is r is 1 in our unit circle. So for an example, to start things off, let's find all trig functions for 5 pi over 6. Well, if you remember, back to when we were dealing with degrees and radians, it might be helpful to switch radians back to degrees, or degrees to radians if you think that way. So if you remember our conversion factor, degrees to radians, you multiply by pi over 180. And for radians to degrees, you multiply by 180 over pi. So let's switch 5 pi over 6 to degrees. So we're going from radians to degrees, so we multiply 5 pi over 6 by 180 over pi. Right, our pi's cancel. 6 goes into 80 30 times. So our final answer is 150 degrees. Well, first order of business is to find our reference angle. So let's draw out our unit circle. 150 is in between 90 and 180, so we're going to be somewhere in our second quadrant, where our angle is 150. So remember, we're in the second quadrant, so we want to find a reference angle by taking 180 minus 50, or we're going to have a 30-degree reference angle. Right, we just said that we're in quadrant 2. So we're going to draw out our special triangle on the unit circle. Remember, the side opposite of my theta, or 30 here, is a 1, making the hypotenuse 2 and the x a negative root 3, since we're in the negative x direction. So now to find sine of our theta, we take opposite over hypotenuse, so 1/2. Cosine will be a negative root 3 over 2. Tangent is a negative 1 over root 3, but remember we have to rationalize that. So we get negative root 3 over 3. Cosecant, we flip sine, so we get 2 over 1, or just 2. Secant, we flip cosine, so we get negative 2 over root 3. We rationalize that by multiplying root 3 over root 3. And we get negative 2 root 3 over 3. And lastly, cotangent, I'm going to flip negative 1 over root 3, so then we don't have to rationalize again. So we just get a negative root 3. So that's using our unit circle to find our 6 trig functions. So number 2 here, use the unit circle to find all values of t between 0 and 2 pi for which cosine t is a half. First thing to notice is our bounds are in radians. So that means our final answer has to be in radians. Next, I'm going to draw out my unit circle. Always a good place to start. You notice that the cosine of t has to be a half. Well, if that's the case, you know cosine of t is going to be positive. So let's figure out what quadrants my answers are going to be positive in. Well, using my all students take calculus trick, I know that cosine is positive in the first quadrant and in the fourth quadrant. So we're just going to not even consider 2 and 3. So my quadrants here are going to be 1 and 4. Well, to figure out what these are going to be, we have to draw our triangles, draw our angles. So if you remember back to special triangles, I'm going to draw a 30, 60, 90 triangle here. The side opposite 30 is 1, hypotenuse is 2, and the side opposite the 60 is square root 3. So the cotangent of whatever angle I'm dealing with t has to be 1/2. So you notice on our special triangle, the cosine of 60 is 1/2. So I know my reference angle then is going to be 60 degrees, or pi over 3 in radians. So my reference angle is pi over 3. Since we're in the first quadrant, I know one of my answers is going to be pi over 3, because in quadrant 1, the reference angle is the original angle. We talked about that in section 3.1. The other angle is going to be all the way around into quadrant 4. So to find that, I have to take 360, or 2 pi, minus my reference angle. So 2 pi minus pi over 3, or 360 minus 60. So I get an angle of 300 degrees, which in radians, if we convert that, remember we're going from degrees into radians now, so we multiply by pi over 180. That simplifies down to 5 pi over 3. So my two answers are pi over 3 and 5 pi over 3. So we're going to switch gears now into probably the most difficult section in this whole chapter, and that's even and odd functions. So an even and an odd function simply means this. If I plug in for an even function, if I plug in a negative x, it's going to spit out f of x. Now let's really dive into what that means. I really don't know what this negative x and f kind of stuff is. So let's plug in some numbers. Let's take x squared, for instance. I'm going to show that that's an even function. So let's pick negative 2. So I'm going to plug in negative 2 here into x squared. Negative 2 squared, the negative sign goes away, and I get 4. Now let's plug in positive 2. Positive 2 squared is also 4. So no matter what number I pick, if I plug in the positive of that number and the negative of that number, it spits out the same value. And that's what it means to be an even function. If I plug in a negative 3 and a positive 3, they're both going to spit out 9. For an odd function, let's look at x cubed. So let's plug in a negative 2 again. Remember, since it's cubed, the negative sign doesn't go away. But it plugs in, I plug it in, and it comes out as a negative 8. What about positive 2? 2 cubed is just 8. So that tells me if I plug in a negative x, so if I plug in a negative number, it's going to spit out the negative of what I would plug in if I plugged in the positive. So negative 2 cubed comes out as negative 8, and positive 2 cubed comes out as 8. So let's try an example here. Determine whether the function is even or odd, or neither. So I'm going to do the same thing. I'm going to plug in a negative 2 and a positive 2. So f of negative 2, so let's just plug it all in. Negative 2 cubed plus a negative 2. Remember, my negative 2 becomes negative 8, but it's a negative of that, so this becomes negative 8 minus 2, or a positive 8 minus 2, which is 6. Let's try plugging in positive 2 now. F of positive 2, I have negative 2 cubed plus 2. My negative 2 cubed becomes negative 8 plus 2, or negative 6. Notice that when I plugged in a negative 2, it became a positive 6. When I plugged in positive 2, it became a negative 6. Remember when we were talking about x squared and x cubed, we knew that for odd function, if I plugged in a negative number and a positive number, the numbers were the same, but the signs were different. Same thing in this example, number 3 here. Plugged in a negative 2 and a positive 2, they spit out the same number, but with different signs. Because of that, this tells me this function is odd. So tying this into some trig functions now. When I take cosine, and I plug in, again, the negative pi over 6 and a pi over 6, let's see what happens in the unit circle here. A positive pi over 6 is in the first quadrant. It's a 30-degree angle. A negative pi over 6 is in the negative 30 degrees, so in the fourth quadrant. I'm going to make this a little bit bigger so we can get a better example, better look at what's happening here. And I'm going to make my special triangles in the unit circle for my 30-degree angles. Remember, opposite the 30 is 1, hypotenuse is 2, and it's square root 3 along the x-axis. For the negative angle, it's a negative 1 going down on the y, positive 2, and still a positive square root 3. So if I look at the cosine of these angles, the cosine of negative pi over 6, or negative 30, is going to be adjacent over hypotenuse, or square root 3 over 2. If I look at the cosine of pi over 6, so positive 30, same thing. I have square root 3 over 2. So if we go back to what we talked about on the last slide about even functions, no matter if I plug in a positive or a negative number, as long as the number is the same, they're the same numbers and the same sign. But what about the sine of these angles? What's the sine of negative pi over 6 or negative 30? Well, that's going to be opposite over hypotenuse, or a negative 1/2. The sine of pi over 6, so the sine of a positive 30 degrees, is 1 over 2. But remember, we have this negative sign right here, and that makes those equal. Because of that, we know that sine then is an odd function. Now these two identities here, that the cosine of negative x is equal to the cosine of x, and sine of negative x is equal to negative sine x, are two identities that we're going to want to memorize. You're going to want to know those. So let's try these out now. Let's do some applied examples. So the sine of negative 60, we're going to draw that on my unit circle. So that's going to be in the fourth quadrant, 60 degrees going in the counterclockwise direction. Let's draw my special triangle in here. So I know then that the x coordinate is going to be 1, the y coordinate is a negative square root 3, and the hypotenuse is 2 again. Now, I know because of the last slide I said that sine was an odd function, which means that sine of negative 60 is negative sine 60. But really, what does that mean here? Let's look at the positive 60-degree triangle. I know that x is still 1. My x-coordinate doesn't change. But I know that the opposite of 60 is going to be a positive square root 3. Hypotenuse is still 2. So if we look at the sine of this positive 60-degree, what do I get? Opposite over a hypotenuse, or square root 3 over 2. Well, what is the sine of negative 60 here? Opposite, or negative, square root 3 over 2. So we look at what we got for sine of positive 60, and we get a positive square root 3 over 2. Well, look back at this identity here. The sine of negative x is the negative sine of x. So if we come back to our example, think of this negative 60 as negative x. And this positive 60 is positive x. My identity told me that I just need to stick a negative sign out front of the sine of positive x. And because of that, it makes the outcomes the same. It makes them both negative square root 3 over 2. So instead of going and drawing our triangles again and having to deal with negative angles, we always want to try to get positive angles in the first quadrant. They're always easier to deal with. So this is why we use these identities. So let's try out number 5, trying to use even and odd function relationships so that we can make it into the first quadrant. The cosine of negative 225. Let's draw out where that is on my unit circle. It's in between 180 and 270, so I'm in quadrant 3. Well, what's my reference angle? It's going to be 225 minus, I drew that in the wrong direction. I apologize. It's a negative 225, so let's draw that correctly. It's always good to go back and check your drawings, because everybody gets them wrong sometimes. Negative 225, so we come around the negative side, and we're going to end up in the second quadrant. So to find my reference angle now, I take 225 minus 180, the same, and I get a reference angle of 45 degrees. So I can draw my special triangle here, drop it down, and I know that my side lengths are 1, 1, square root 2. Remember, the x is in the negative direction, so it's a negative 1 along the x-axis. But if we go back to the previous slide, we said that the cosine of a negative x is equal to the cosine of a positive x. So if I look at this cosine of negative 225, it should be equal to the cosine of positive 225. Well, let's look at another unit circle where I draw out a positive 225. Going around the positive direction, we end up in the third quadrant. Well, I draw my special triangle again. We also have a 45-degree reference angle. So my side lengths are going to be negative 1, 1, and a positive square root 2. My apologies, a negative 1 going in the y direction. So what are the cosines of both of these angles? Well, on the positive 225 one, which is the left one, the cosine of 225 is adjacent, negative 1 over root 2. Rationalizing, we get a negative root 2 over 2. Well, let's go to this second unit circle with a negative 225 degree angle. The adjacent is negative 1 again over the hypotenuse, root 2. Or rationalizing, negative root 2 over 2. Notice they're the same. So we can use our even and odd function relationships to say, all right, I just showed that the cosine of negative 225 is equal to the cosine of a positive 225. So we can maybe only deal with positive angles using these two relationships, which is a great thing, because negative angles are pretty terrible. They can get pretty nasty. So a really deep applied problem now is using these even and odd function relationships to prove identities. Remember, the cosine of a negative angle is, as we showed in the previous slides, equal to the cosine of a positive angle. So if we use that identity now in trying to prove this identity here, cosine negative theta times tangent theta equals sine theta, I'm going to use this even function relationship, which tells me then that the cosine of positive theta times the tangent of theta is we'd want to show that is equal to sine theta now. Let's rewrite tangent theta. We know tangent theta is sine theta over cosine theta. My cosine theta is canceled, and I'm left with sine of theta. Smiley face at the end. So we can even use these even and odd function relationships to prove identities, which is going to come in really handy later on. So go ahead and write your summaries and any questions you have, and take a look at the assignment for tomorrow.